Hey, so in this video I'm going to talk about our variable initialization options and the fact that we can have multiple declarations or initializations per statement. We'll start off with the variable initialization options. Initialization again refers to the starting value or configuration of a variable. In the first statement we declare a variable p, so int p and the semicolon. Now the variable p is uninitialized, so it's going to contain garbage. In the next statement we declare and initialize the variable q, also of type int. That is basically the older C-style initialization. In the next statement we declare a variable r and we use constructor initialization, or in other words the parentheses, to initialize the variable r to 4. In the final statement we declare a variable s and we initialize that using list initialization, also referred to as brace initialization. It uses those curly braces, so in this way we can initialize s to 3. This brace or list initialization was introduced in C++11. A couple of notes here on the brace or list initialization. Empty braces will initialize the variable to 0. Brace initialization will also do a check at compile time to make sure that the value is not too large and can actually be stored in the variable. If some implicit conversion happens from some larger value to an integer type, for example, then you will get a compiler error, and this is very handy because it eliminates all sorts of problems that can pop up, and I'll show an example in Visual Studio later. We can also do multiple declarations or initializations per statement, and we can do this by using the comma operator to separate out the initializations or declarations. Also, it depends on how you initialize your variable. So in the first example, we declare x, y, and z. So we have multiple declarations x, y, and z in one statement, but those are now uninitialized. So in the next statement, we go and initialize those. We use x, the assignment operator, and 0, comma, y, the assignment operator, and 1, comma, z, the assignment operator, and 2, and we end that off with a semicolon. Then in the next statement we use parentheses or the constructor style initialization. So in this way we declare and initialize the variables p, q, and z. P to 0, q to 1, and z to 2. Okay, so declaration and initialization in one statement. Similarly, we can use brace or list initialization to do multiple declarations and initializations in a single statement. We declare the variables m, n, and o. Then we use list or brace initialization to initialize those variables. With the variable n we pass in 1 for initialization, and with o we pass in 2 for initialization. But notice with m, the braces are empty, and that is going to initialize m to 0 by default. In future lessons we are going to use the list initialization to initialize lists such as arrays, and also classes and structs, and we'll talk about that in the module C++ 102. So that will then initialize every element, or in other words every variable in that container, to 0. That makes debugging much easier because you don't have weird values that show up. A quick example in Visual Studio: in the main function I declare p, q, and z, and I initialize it using list initialization. P, we use empty braces, so that is going to initialize p to 0, and then for q we initialize q to 1, and we initialize z to 2. And we separate out the declarations and initializations using the comma operator. Then I simply print those values out, so I do cout p, cout q, and cout z. In the next statement we do integer x, and we initialize it to this value right here, a huge integer value, and then we print that out. Let's go and build and run this. And we get 0, 1, and 2, and then we get this huge value right here. As we'll see in the next lecture, we have types that can store really small values, and we also have types that can store really large values, such as longs, for example. Now what if the value that you want to store is too large for that particular type? So in this case, if I change the 7 right here to an 8, I'll just build and run this again. And all of a sudden this is now a negative value. Similarly, if I add another number at the end, so let's say I do 5 here, build and run that, again we'll get this weird value now, we get 5. That is not what we have right here, this is not 5, right? We'll get something called an overflow error, and that's going to happen because the particular type, so in this case integer, only has so many bits available to it in memory, and because of that it can only store values that are that large. Remember, with integers we can store both positive and negative values, so it has to cover a huge range of values. As we've seen, if you try and store a value in a variable that is too large for the particular type of the variable, then we'll get an overflow error, and the value that it stores will not be what we actually want to store. Now we actually do get a warning, so I'll go to the output, and you will see warning here, a truncation from an int, a 64-bit int, to this int right here. And basically it's doing this implicitly or automatically, and to avoid that, what we can do is we can use brace initialization, and instead of getting a warning we'll get an error. Okay, use list initialization, and I try set x to a value that is too large to be stored in an integer, and Build and run that and we'll get an error. Conversion from a 64-bit integer to an integer requires narrowing conversion. Okay, so that's great. We get a compiler error instead of running our program and we get some weird values. I'll just go and clean this up here. I'm going to change list initialization to the constructor, or in other words the parentheses style initialization. This is important. We'll actually get an error here with this initialization. When you use the parentheses, or in other words the constructor style initialization, you must pass in a value such as 0, for example. Okay, let's just leave it empty for now and Control F5 to build and run, and you'll see we get an error. We'll get this weird error right here. Unresolved externals or something like that. Now that's because this is actually a function declaration, not a variable declaration, and we haven't defined the function anywhere. And we'll talk about functions in more detail later, but basically to avoid that you want to pass in some value here. So 0, for example, so that we have 0, 1 and 2. And build and run, and this works fine. We get 0, 1 and 2 printed out, and we don't get any errors. Quick recap: when you use the constructor or parentheses style initialization, you must pass in a value for the initialization. Okay, so that is the difference between brace initialization and parentheses initialization. I would like to note that you can also do this, so you can also use the assignment operator with these. Like that. Build a run and you'll see that works fine. And the same thing with the brace initialization. Build a run that and you'll see that works fine. But of course it's much shorter, you don't have to use the assignment operator. You can just write it like this. We'll talk about the differences in a bit more detail with our custom types in the C++ module 102. This is typically how you would do it. You would not use the equal sign. That is in the case when you do initialization by using the braces or the parentheses as styles of initialization. Quick examples for you, and you can see in main we have int my age and your age. That is multiple declarations per statement. We use the comma operator to separate those out. Then in the next statement I initialize my age to 97, your age to 18. Then in the next statement I do multiple declarations and initializations in one statement. Again, this is the oldest C-style declaration and initialization. You can see we have int x. I initialize that to 3 using the assignment operator, comma y, the assignment operator, and 4. Then in the next statement I declare a variable z also of type int, and I initialize that to x multiplied by y. So we are going to initialize z to 12. I just wanted to provide another example of where we can use an expression to initialize a variable. So to the right we have that expression, the multiplication operator, x and y as operands, and we initialize the variable z to whatever that evaluates to. Then I do cout your age is, and I print out your age, and then I do cout z is, and I print out z.